Assalamu alaikum warahmatullahi wabarakatuh. Dear students, our today's session is on probability distributions, and especially we are talking about discrete and continuous models. And as you know, we have already discussed in greater detail the difference between discrete and continuous, but very much simply, discrete is talking about the numerical measurements which are in whole number, such as we can say two persons, three persons, two rooms, three rooms, two men, three men, four men. We cannot say 2.5 men, 2.5 rooms, 1.5 classes. Why? Because all of these are whole number and they cannot be in fractions or decimals. But in continuous, the variable can take any value, any measurement. In continuous, we can have numbers in fractions or in decimals, like we can say a 1.5, 1.3. In the height of individuals, we say 1.65 centimeters, 1.70 centimeters. So you can say continuous can take any value, while discrete is whole number that cannot be in fractions or decimals. So in today's sessions, we are talking about the probability distributions covering both discrete and continuous models. Okay, dear students, and the probability distributions. First, we have three type of distribution. One is binomial and Poisson, and the third is normal distributions. Okay, the Poisson is also called Poisson. Sometimes in the pronunciation is Poisson. Okay, both of them are correct. Binomial and Poissons. Okay, for discrete data, we are using binomial and Poissons, but for normal distributions, for continuous data, we are using normal distributions. Okay, first I'm explaining what is binomial distribution, dear student. In binomial distributions, when you have independent number of trials, like n, okay, and you are interested to know the probability of either success or failure. If you categorize the number of independent trials in two classes or in two groups, right, and we call one group is success and another is failure, and now you are interested to know what is the probability of success, right, or what is the probability of win or the probability of pass, then we are using binomial distribution. That's why it's called binomial. There are two possible outcomes. We are interested to know about one of them. Okay, so one we call it success or another is failure. Okay, here we have an example. For example, when you flip a coin 5 times, what is the probability of getting exactly 3 hits? Okay, now when you flip a coin 5 times, so there are many possible outcomes. In the first, you can get heads in the first turn, and heads in the second turn, heads in the third turn, heads in the fourth turn, and heads in the fifth turn, right? Okay. Also, you can get in the first 4 turns heads, in the last turn you can get tails. Also, you can get in the first 3 turns you can get heads and then tails and then heads. So in this way, there are 32 possible events, or this is the sample space of all 32 possible events we may have. Now, a question here is, we just classify this the number of independent trials here we have into two groups. I'm just interested to know what is the probability of getting 3 hits in the set of whole numbers. Okay, so the probability of getting 5 hits we have here is 5 hits, but we are interested about the probability of getting just 3 hits. Okay, the order doesn't matter. Okay, so we have 4 hits here, 5 hits here, we have 3 hits here, okay, 4 hits here, but the number of events where we have only 3 hits, okay, when you just sum them together, the number is 10. Okay, so in 32 possible event, the number of 3 hits, that is 10. So 10 divided by 32, that is given 31.25% simply. But it's not really easy just to find out the sample space of all possible events, and then you should count how many 3 hits are there, and then you divide it over the total number. It's really difficult. We have a function, we have formula. Just put it in this formula, right? This is a function we are using this. Okay, for this formula we need number of information. For example, first you need number of trials. Okay, number of trials is when you flip a coin 5 times, so the 5 is the number of total independent trials you have. Okay, now we are interested about the success. The success here is the 3 hits. We are interested to know about how many 3 hits we have in total number of trials. And now the third information you must have is that is the probability of one coin, one turn. Okay, when you just flip a coin one time, one only single time, what is the probability of hits? That is 0.5. So for doing this, right, and finding out this result, you must have three informations: the number of trials, okay, the number of success, okay, you are interested about getting three hits out of the total, the probability of getting three, and also you must have the probability of single turn. Okay, when you flip a coin one time, what is the probability? That is 0.5. Once you have these three information, just plug it here in this function or in this formula. Okay, in this formula we have the probability of capital X, which is, this is the number of success we are interested now about, and this is n choose x. Okay, and this is, we have a special functions to find out n choose x. We have n factorial or x factorial into n minus x factorial, and then you should multiply into the probability, right, and raise into power x, and also multiply into 1 minus p raised into power n minus x. Once you have all this information here, then plug it in this formula, right? When you plug it in the formula, we have 5 over 3. You should find out the 5 factorial, and then you should find out the 3 factorial and 5 minus 3 factorial, as I've explained here already. Okay, simply you can use, and now after that plug all these values in the formula, you can get an answer, and that is 0.31 at 31.25%. So you can say the probability of getting three hits in the number of 32 independent trials, that is 31.25. But dear students, keep in mind, this is just the concept behind. You just learn what is the concept of binomial distribution. But we have softwares, we have program, right? You can just use Excel, Stera, EV, SPSS, any software. You can use it just to find out this answer very much simply. Okay, now we have one another example. Here we have a scenario. In a given year, students appear for the Concord examinations. Although many pass the exam, not all proceed to university admissions. Historically, only 70% of past students take actual admissions, okay, to continue their education. Now, dear students, in this question, we have a question. If 20 students have passed the Concord exam, what is the probability of exactly 10 of them? Okay. Now, the number of trial here is 20 students. We know if 20 students have passed the Concord exam, and now these 20 students, they are interested to get admission, right? Now, after Concord examinations, once the 20 students get admissions, we just try to know what is the probability that exactly 10 out of them will get admission. Why? Because most of the time, students who pass Concord, all of them, they are not taking admission. Some of them, they quit and leave. So we are just interested to know what is the probability that exactly 10 out of 20, if they pass Concord exam, will take admission. Okay, so this is the same question like the previous. But for this information, the third information you need is the probability. We already know that from the previous record and the historical data that those students who pass Concord, so out of them 70% they got admission. This is the historical data. Once you have all these three types of informations, then you just plug it in the formula and you can get an answer. But have to do it in Excel. Come here. Okay, dear student, we have 20 students. These are the number of trial. The number of trial, 20 students. Now, we know historically the probability is 70%. 70% they get admission. Now, we just try to figure out what is the probability that exactly 10 students will get admission. If there are 20 students, they have passed Concord exam and they are ready for admission. What is the chance that the 10 out of them exactly will take admission? So for this probability, okay, very much simply, equal sign, we have binomial distribution. Click on binomial distribution, and what is asking number? Okay, number we are interested to know, that is the success we just tried to know about, and then trials, the number of total trials, we have 20, and the probability must be given. Okay, all these three informations, once they are given, you can use a formula, but that's too difficult, not easy, right? Time consuming. So you can just use Excel here. Instead, put it here in this function. Okay, then next they are asking cumulative or okay. Here we have, if we just try to find out the probability which is cumulative, inshallah I'll talk about later, or you are interested to find out the exact probability. We are interested about the exact probability, so that's why you should choose false. You should choose false. Press enter. You can say the probability of 10 students to take admission, that is 3.08%. Okay, dear students, this was just the binomial probability. But now, just I try to find out the binomial distribution. What is distribution? I just try to find out what is the probability of 1 to 20. Okay, so I just type 1, 2, 3, 4. Okay, and drag it to 20. Now, I ask a question. If there are number of independent trials, right, which are 20, in the probability of single event, that is 0.7, 70% of students probably take admission. That's clear from historical data. Now, here we found out just simply one probability. But what if you just try to find out the probability of number of different other probabilities, for example, starting from 1 into 20. Okay, so when you just try to find out the probability of one student to get admission, the probability of 2 or 3 or 4 or 5 in this way up to 20, this is what is called probability distribution. We are just interested to know about the group of different probabilities. So starting from 1 up to 20, you should not increase our from 20. Okay, this should be the maximum limit because our n is 20. Okay, just put equal sign here and we have binomial distribution. Click on binomial distribution here. Okay, what is number of s? This is what we are interested here, number of s in the number of trial, that is 20. But keep in mind we should stick into this value because when we drag it down, so this reference should be stuck into. Okay, just press F4 and then comma, and then what is asked here, trials. Okay, this is the trials we enter. The third is the probability. The probability is 0.7. Click here and press F4, and then again this is exact probabilities, that's why you should put false. Okay, press enter and drag it down. Okay, now look, dear students, here we have the probability of 1, 2, 3, 4 and different student up to 20. What is the interpretation? As you can say, if there are a number of uh, independent trials, 20 is the number of independent trials. Okay, if 20 students take exams, Concord exams, and they pass Concord exam, all right, the probability that one will get admission is 0.00 and 2 is 0.00. The probability that 4 will get admission is 0.001. Okay, and the probability that 5 will get admission is 0.004. In this way, so you can say the highest probability is for 14. You can say 14. This is very much probable that 14 individual will take admission. If 20 are enrolled in their past Concord exams, so you can say 14 out of them, right, they will get admission. Okay, so our example for x, which is 10, that is 3.08. You can just check it in the distribution also. Why? Because if 20 get enrolled, the probability of 10 is 3.08. We have already found it out, but here we have the distributions. We have the probability for many students from starting from 1 up to 20. Okay, dear students, now if you graph this, click here simply, right, and click on insert. Within insert, okay, you should choose bar graph. Why? Because for discrete values we are using the bar graph. So in this graph you can see from 1 into 6, you can say almost there is zero probability, but the probability chance is starting from 8 and the highest probability is for 14. You just see how the values, they are clustered around the central value, or that is clustered around, right? You can say this is the 14 is the most probable value, and then the next probable is 15, and then 13. We have to eliminate this way. Okay, the concept, dear student, is that you just try to know the probability of success. Number of trials, independent trials must be given, and now you just try to know what is the probability of 10 students to get admission. Okay, given that the probability of the event, that is 0.7 or 70%, historically the data, this probability must be given. Okay, hopefully, dear students, you got what is binomial distribution. Okay, in the next section, inshallah, I'll discuss Poisson probability.